Welcome to my classroom. In this video, I start with a simple problem looking for a minimum distance and solved by refraction of a point about a line. This technique is applied to solve another 5 problems. The technique is simple and the problems can be challenging. The video is for students of all levels. The first problem is quite standard and can be found in exercise for junior form. Referring to the figure, A and B are points on the same side of the line L. A student walks from A, which is L, and goes to B. How should the student travel in order to walk with minimum distance? Suppose the student reaches point P on L. Then the distance traveled equals to AP plus PB. Here, A and B are given, and therefore they are fixed points. P is a point which can be varied. We would like to choose a suitable location for P so that AP plus PB is smallest. How to find this point P? We can make use of refraction. Refract A about L. By refraction, it means to drop a perpendicular from A to L. Let the intersection point be O. Extend AO to A prime, such that AO equals to OA prime. The point A prime is the image of A under the refraction about L. Consider the triangle PAA prime. Since PO is the perpendicular bisector, we have PA equals to PA prime. So to find AP plus PB, it is equivalent to find A prime P plus PB. As A and B are fixed points, P is a variable point. Move P such that A, P, and B are collinear. In this case, by the principle that straight line gives the smallest distance between 2 points, we have A prime P plus PB is minimum. So, the minimum distance is given by A prime B. The minimum distance can be calculated by Pythagoras theorem. Make sure you understand every details of the solution before going to the next problem, including fixed points and variable point. Refraction of a point about a line. When 3 points are collinear, the distance is minimum. It helps you to understand more how the other problems are solved. This problem is quite similar to problem 1. Given 2 points A and B. This time, 2 axes are considered instead of a line. So, 2 variable points P and Q are involved, and find the minimum value of AP plus PQ plus QB. It is good to pause the video and work on your own to ensure you master the technique discussed in problem 1. Here is the solution. Refract A about the y-axis to A prime, so the coordinates of A prime are -1, 4. Refract B about the x-axis to B prime, so the coordinates of B prime are 5, -2. Since AP equals to A prime P and BQ equals to B prime Q, the minimum distance occurs when A prime, P, Q, and B prime are collinear. So the minimum distance is given by the distance between A prime and B prime, which is 6/2. This time, given 1 point and 4 lines forming a rectangle. Let A be the given point. P, Q, R, and S are 4 points on the sides such that AP plus PQ plus QR plus RS plus SA is minimum. You may pause and work on your own for the challenging version of this type. The idea of the solution is similar to the previous 2. It just takes more refractions. First, reflect A to A prime. So AP equals to A prime P, and A prime, P, and Q are in the same direction. For R, it is better to draw the rectangle to show the reflection clearly. Reflect R to R prime. Draw a further rectangle to show the next reflection. Reflect S to S prime. Back to A, reflect A to A double prime. As A is a fixed point, so as its image A prime and A double prime. P, Q, R, S are variable points. Move them so that A prime and A double prime form a straight line. The distance between A prime and A double prime gives the minimum value for the answer. To calculate the answer, give coordinates to the points. Regard A as 2, 1. So A prime is the point with coordinates -2, 1. For A double prime, this point is 8, 6, and this one is 16, 12. So the coordinates of A double prime are 14, 13. By the distance formula, we have the minimum length, 20. This time, we are given 2 points A and B, and 2 lines which form an angle of 20 degrees. P and Q are variable points on the arms of the angle as shown in the figure. Again, find the minimum value of AP plus PQ plus QB. Pause and try. Like the previous problems, reflect some of the points so that they are lying on the same direction and make use of a straight line to find the minimum distance. For this problem, reflect Q about line OB and mark the image as Q prime. We see that Q prime lies on the arms of an angle of 40 degrees from the baseline. Do the same for point B. Mark the image as B prime, which lies on the arms of an angle of 60 degrees from the baseline. The minimum values occurs when A, P, Q prime and B prime are collinear. In other words, the minimum value is given by the distance between A and B prime. Consider the triangle AOB prime, which is defined by SAS. The length 4, angle 60 degrees, and the length 8. By cosine formula, we have AB prime equals to 4 root 3, the minimum value we look for. In this problem, an angle of 40 degrees is considered. The given point C is inside the angle as shown. P and Q are variable points on the arms of the angle. This time, we are asked to find the angle PCQ when the perimeter of the triangle CPQ is smallest. The structure of the problem is different from the previous ones. Pause and try. We first identify the location of P and Q when they give the minimum perimeter of the triangle. So reflect C about 2 arms to get the images C prime and C double prime. For minimum perimeter, C prime, P, Q, and C double prime are collinear, or simply C prime and C double prime form a straight line. Mark these 2 angles as alpha and beta. Due to refraction, these 2 angles are also alpha and beta. Since these 2 angles are 90 degrees and the given angle is 40 degrees, so angle C prime C double prime is 140 degrees by angle sum of quadrilateral. Let me denote the angle PCQ by X. Then we have alpha plus beta plus X equals to 140 degrees. On the other hand, consider triangle C prime, C double prime. We have 2 alpha plus 2 beta plus X equals to 180 degrees. Combine these two results. We have x equals to 100 degrees. That is, the answer is 100 degrees. This is a problem on coordinate geometry. Given the coordinates of point 8 and the equation of line L, P and Q are points on L and x-axis respectively. Find the minimum value of AP plus PQ. Pause and see if you can apply your understanding of minimum distance to find the answer. We first reflect the point A about the line L. Denote the image by A prime. AA prime is a line perpendicular to L. Therefore, the slope of the line AA prime is the negative reciprocal of L, that is -2. By point slope form, we get the equation of the line AA prime, y equals to -2x plus 16. Let x coordinates of point A prime be alpha. Then the y coordinates is -2 alpha plus 16. As A prime is the refractive image of A about L, the midpoint of points A and A prime lies on line L. By the midpoint formula, the midpoint of A and A prime is alpha plus 8 over 2, negative alpha plus 8. Put the midpoint into the equation of L. We have alpha equals 6. So we get the coordinates of A prime, which are 6, 4. For minimum value, we have A prime, P, and Q are collinear. So we only need to think about the line segment A prime Q. Since A prime is the image fixed by A, and Q is a variable point on x-axis, the length of line segment A prime Q is shortest when A prime Q is perpendicular to the x-axis. Therefore, the minimum value of the length A prime Q is given by the y coordinates of A prime, which is 4, the answer. We have done 6 problems on minimum lengths and solved by suitable refractions. To consolidate and master the technique well, it is good to study the problems more carefully. You may think about the following questions. What kind of problems can be solved by refraction? What is the point of using refraction? What is the difference between fixed points and the variable points? What kind of points are refracted usually? How to determine the minimum length? If you have a clear understanding of this technique, you are able to apply the techniques to solve other similar problems, even they are presented in a different way. I believe learning with clear understanding is a good practice to enhance your problem-solving skills.